Humans have always been curious about their capacity to exist beyond Earth. If we think about space without the protection of Earth's atmosphere and its greenhouse effect, it is essentially an unimaginably cold, pitch-black void. In such conditions, it's hard to imagine any life form thriving. In the last 60 years, numerous space journeys have taken place. It's impressive that none of these journeys led to any deaths. It's important to note that the accidents did happen, like the Apollo 1 incident, the Challenger disaster, and the Columbia disaster, were not caused by issues with spacesuits. With that said, let's delve deeper into how we made it possible to exist in space. Imagine trying to carry a bit of Earth's atmosphere and environment with you wherever you go. That's the core concept of surviving in space. The goal is to create a pocket of space where factors like air pressure, air quality, and temperature remain constant, mirroring Earth's conditions. This idea was something humans began to experiment with way before space travel was even a reality. Back in 1932, a brilliant Swiss physicist by the name of Auguste Piccard decided to see just how far he could push human boundaries. He took a daring journey on a helium balloon that reached an astounding altitude of about 52,000 feet. Understanding the danger of thin air and reduced oxygen at such heights, Piccard ingeniously crafted a pressurized aluminum sphere, filling it with breathable air. Many of us know that breathing becomes more challenging as we go higher in altitude. This is evident when people climb mountains, but the decrease in atmospheric pressure is even more perilous in reduction in oxygen. Pressure affects the boiling point of liquids. As the atmospheric pressure goes down, liquids boil at lower temperatures. Considering our bodies are mostly fluid, this is concerning. At an altitude of 63,000 feet, water starts boiling at our body's regular temperature, 99 degrees Fahrenheit. If the pressure isn't maintained, regardless of how much oxygen you have, things will go terribly wrong. Flying in a pressurized balloon can help deal with high altitudes, but what if you want more adventure? Think of the American pilot, Wiley Post. He wore an eye patch, earning him the nickname Willie One-Eye. Wiley built a fast plane called Winnie Mae to fly super high as about 50,000 feet. He hoped to set records using the jet stream. Imagine trying to drive your car on a highway at the top of Mount Everest. It's a similar challenge. However, Wiley knew that going that high might be tough on his body. So in 1934, he worked with B.F. Goodrich, a car tire company, to make the first pressure suit, like an early version of an astronaut's outfit. The suit was made up of 3 different parts. First, there was long underwear that sat close to the skin. Next, a layer of black rubber helped maintain air pressure. Lastly, there was a material that was similar to what was used in parachutes. This entire suit was attached to a frame that had arms and legs that could move. This allowed the person wearing it to manage the plane and also walk when needed. For the hands, there were gloves made of pigskin. The feet were covered in rubber boots. The head was protected by a helmet made of aluminum and plastic, similar to what divers wear underwater. Interestingly, it was the United States Air Force who first made these truly effective suits. Before that, there were some not-so-good versions made by less knowledgeable people. In the 1940s, big bombers started flying at heights of over 40,000 feet. Planes like the B-36 Peacemaker could now fly at these great altitudes. Before this, pilots only needed oxygen masks, but these new planes were meant for combat. If they got damaged in battle and had a hole, the pressure inside the plane would quickly drop. This is why there was a need for special pressure suits and helmets for everyone on board. Then, in the 1950s, America made the U-2 spy plane. This plane was amazing because it could fly at 69,000 feet high. This was higher than the range of Soviet defense systems. But pilots flying so high faced a risk. Their blood could start boiling because of the reduced pressure. So, a new suit was designed specifically for them. By the end of the 1950s, both the US and the Soviet Union were getting ready to send humans into space. This was a huge challenge. The US Air Force started using the X-15 rocket plane to test very high-speed flights. They also developed the XMC-2, an upgraded pressure suit that improves survival chances in extreme flight conditions. This is where our modern idea of the spacesuit began to take shape. Now, while we have talked a lot about American suits, it's worth noting that the Soviets made history too. Think of Yuri Gagarin, who was the first person to wear a real spacesuit in space. He zoomed around Earth really fast, about 17,000 miles per hour, and his journey was about as long as a movie, lasting 108 minutes. But here's the cool part. When it was time to land, his space capsule couldn't touch down safely. So, he jumped out of a height similar to flying about 4.5 miles high and used a parachute to land. NASA had a big goal for the Gemini mission. They wanted to learn a lot about how things work in space and do it quickly. President Kennedy's big dream inspired them. He had said that before the 1960s ended, Americans would walk on the moon. Even though he was no longer there, NASA was determined to make this dream come true. One of their hardest tasks was creating the perfect spacesuit for walking on the moon. This new lunar suit needed some big changes. Astronauts needed a self-sustaining life support system instead of just a tethering cable like in the Gemini missions. They needed to carry large backpacks because being on the moon required more gear. Even though the moon has a weak gravity, it was not easy for the astronauts to move. They could easily lose balance and fall over. So, the spacesuit had to be strong and protective. The outer part of this new suit was made of a special material, silica fibers woven together and then covered with Teflon. Inside the suit, there was a system of bellows and movable joints. This ensured astronauts could move easily, even when faced with a lot of pressure. To keep the astronauts cool, water was circulated through cooling tubes inside the suit. When on Earth, the whole suit and backpack weighed 209 pounds. But on the moon, it felt a lot lighter. Thanks to this suit, astronauts like Neil Armstrong and Buzz Aldrin could actually walk on the moon's surface. This was a huge win for NASA. Every astronaut who went on the moon had a suit like this, and they all worked perfectly. After the success of the moon missions, NASA started thinking about having people live in space for longer periods. They imagined settlements in space and more humans staying close to the Earth in orbit. For these new goals, NASA knew they needed an even better spacesuit. Inspired by the Apollo lunar suit, NASA developed the Extravehicular Mobility Unit, EMU, for the Space Shuttle program. These spacesuits were different. They were heavier and more rigid. The EMU was made in a modular way. This meant the parts of the suit came in different sizes to fit all astronauts. One cool feature of the EMU was a new jetpack. Astronauts could use it to float in space without being attached to their ship. The EMU was tested in real space conditions in 1990 when astronauts worked on the Hubble Space Telescope. The telescope was placed higher than the International Space Station, making the job quite tricky. To help astronauts get ready for these spacewalks, NASA created a place called the Neutral Buoyancy Laboratory. Over the years, the EMU suit was improved. They added things like simple thrusters for easy movement, better heating for gloves, and longer-lasting batteries. Today, when astronauts do spacewalks on the ISS, they still wear these improved EMU suits. The spacesuit that Americans have used in space hasn't really changed much since it was first made. However, with the upcoming Artemis 3 mission, where humans will go back to the moon, there needed to be some changes. On March 15, 2023, a company called Axiom Space showed everyone a new design for NASA's Extravehicular Mobility Units, EVMUs. NASA decided to let Axiom design this new suit because they felt they needed some outside expertise for creating a modern lunar suit. What Axiom did was pretty impressive. They took all the lessons and knowledge from past space missions, especially the ones using the Space Shuttle and the International Space Station, and combined this with the experiences from the old EMU spacesuit. With all this information, Axiom made a suit that gives astronauts the ability to move freely, which is super important for long stays on the moon. One thing to note is that the goals for the Artemis mission are different from the earlier Apollo moon missions. During the Apollo missions, astronauts would land on the moon, spend a few hours exploring and doing some experiments, and then come right back to Earth. But with Artemis, things are more ambitious. The plan is for astronauts to stay on the moon for weeks. They won't just explore, they're going to start building a permanent base there. This is a huge task and means the astronauts will be doing a lot of physical work. So, their spacesuits have to be comfortable, tough, and allow them to move easily to get the job done. Now, with the new spacesuit designed for the moon almost ready, people are already thinking about the next big challenge. The dream is to send humans to Mars, which is much further away than the moon. For a trip like that, astronauts will need an even more advanced spacesuit. This Mars suit is still just an idea, but scientists and engineers are excited to start working on it. Imagine a suit that can handle the harsh conditions of Mars, where there are huge sandstorms and very cold temperatures. The spacesuit would also need to support the astronauts for long periods, since a trip to Mars could take months. What's the next big leap in space exploration, and how will future spacesuits shape that journey? Share your thoughts, let us know in the comments, smash that like, and subscribe for more.